Good day, students. Today, we will learn about metallic bonding. Definition of metallic bonding is the force of attraction between number one, positively charged metal ions. And number two keyword is a sea of delocalized electrons. Now, there are two parts to this definition. Metallic bonding is a force of attraction. As well, each time you have a force of attraction, remember always to state which are the parties involved. In this case here, the positively charged metal ions and the sea of delocalized electrons. Allow me now to explain how number one and number two comes about in the context of a metallic bonding. Consider with me a number of your potassium metal ions arranged in this manner. Now, students, these are atoms. But, however, if you realize from your learning of ionic bonding, metals tend to lose their valence electrons. They tend to want to lose their valence electrons to obtain a stable octet or duplet configuration. So, what happens in this case here, in a typical metal, right? Each of this potassium atom, and if you were to recall with me which group potassium is in, potassium is in group 1, each of these atoms will tend to lose its one valence electron to become K+. When this happens, students, each of this, there's 8 of them here, each of them will lose 1 electron. Now, this electron will not stay near the atom which loses it, but however, this electron will be delocalized among all these metal cations. 1, 2, 3, 4, 5, 6, 7, and perhaps one more here, 8. Now, these electrons will basically be moving all around this metallic cations. So what happens in this case here? You have a positively charged metal ions over here, as well as a sea of delocalized electrons, which is moving around here. So what happens, students, in this case here, is that because your sea of delocalized electrons is negatively charged and the positively charged metal ions are positively charged, they will have a force of attraction. Now, if you are asked to actually draw this structure, usually you do not have to draw like what I do. Rather, you can just do something like this. Very importantly, students, you need to draw circles. And you can just put plus inside. So, very importantly, students, you also need to put the electrons in. So in this case here, okay, there's 8 atoms. So put in 8 electrons. Now, students, in this case here, always make it a point to label. So what we will do is, these are what we have the C of delocalized electrons, and label, students, here the positively charged metal ions. And this, student, is what we call metallic bonding. Now, students, what then are the properties of metallic bonding? Students, metal, as you all know, okay, are able to, number one, conduct electricity. Students, they are able to conduct electricity because of the presence of delocalized electrons. Okay, these delocalized electrons are able to move freely to allow for the conduction, to conduct electricity. Next, students, you also know metals are good conductors of heat. Now, students, they are able to conduct heat. Once again, it's because of the presence of delocalized electrons. Now, these electrons are mobile, and for that matter, they facilitate. Facilitate basically means it makes something easier. It facilitates heat transfer. Okay, facilitate heat transfer. So that being the case, you also realize that for most metals, right, they actually have high density. High density. Why is this so? This is because, as you can see, due to the attraction between the sea of delocalized electrons and the positively charged metal ions, the layers of your metal cations are packed tightly. Next, last but not least, one very important property that you will always remember is that metals, metals, right, are malleable and ductile. And why is this so? The key word here is because when I apply a force on metal, these layers of metal ions are able to slide over each other without breaking. The sea of delocalized electrons will keep them attracted to each other and they won't break. Now, to put it into words, it simply means that when a force is applied, okay, I'm going to write here, okay, okay, here, what happens is the layers of metals, okay, slide, the keyword here is slide, okay, over each other, okay, slide over each other through, okay, through the sea of delocalized electrons. And since the question most likely sometimes you ask, why is it they do not break? You will always end off with because of layers of metal sliding over each other. Okay, what happens is that these metals slide over each other through the sea of delocalized electron. This results in the metallic bond remains undisrupted. So, students, for metallic bonding, you basically just need to know the definition over here. Okay? And you will also need to remember the 4 properties, okay, of metals, and to explain in terms of metallic bonding. So, student, this is a very short video on metallic bonding. And just one last thing, because of metallic bonding, the structure that metals have is what we call a giant metallic structure. So this, student, is a structure, okay, that metals have because of metallic bonding. Thank you.